Welcome to ClickMyProject.com. Let we discuss about the process prostate segmentation in MR images using discriminant boundary features. Let me see the abstract of the process. Segmentation of the images refers to the extracting the needed region of interest from the image based on some specified methodologies. The segmentation methodologies are commonly based on thresholding, that is, the regions within the particular range or pixels that were having particular value. Edge detection, contour extraction, clustering are all common segmentation methodologies. Edge detection identifies the edge points around the needed objects. Contour extraction refers to outlining the segmented portion from the image. Clustering refers to producing separate identifications, that is, color contour differences for the regions in the images that are similar in intensity or similar in color. The images containing tumorous portions were collected. The obtained images were trained. The test image is pre-processed in order to remove the noises from the image using median filter. Threshold is applied to the image based on the regions in the images. Based on that, the regions in the images were segmented. The region of interest is selected from the threshold applied image. The region of interest containing the tumorous and the non-tumorous portions. Corner points were identified from the images based on the shift descriptors, and the neighborhood regions around each points were extracted were taken. The features were extracted from the neighborhood regions and the values were saved as the features. While training, each neighborhood regions were labeled as tumor and non-normal regions. Fuzzy rules were generated for the features obtained, and based on the generated fuzzy rules, each neighborhood portions were identified as tumorous or normal regions. The neighboring regions that were identified as tumors were whitened and the remaining portions were blackened so that the tumor portions is segmented separately. The performance of the process is measured with the help of the accuracy of the segmentation process. Let me see the flow of the process. First, input image is taken from the dataset. The pre-processing process is done based on the median filter process. Then thresholding process is applied to the filtered images. The filtered image is segmented using the parent algorithm, that is the thresholding process. The pixels which are below the particular threshold were taken and the obtained pixels were segmented from the input image. This process initializes the segmentation of the image. The segmented regions contains the tumorous and the non-tumorous portions. The regions within the segmented region, which contains the maximum area belonging to the tumorous portions, were taken. The images within the area that were having the maximum area were alone taken from the original image pixels. Then the seed point selection using the shift descriptor were employed. Shift descriptors were extracted from for the segmented portions. The shift descriptors gives the seed points within the selected regions. The neighboring pixels within a particular size around the seed points, that is the range of 10 cross 10, were selected. In the training process, the selected regions were labeled as tumorous and non-tumorous portions. The features were extracted for the selected regions around the seed points using gray level co-occurrence matrices. The extracted features were accessed to texture-based information for the image. In the training process, the same process is repeated for all the images in the dataset, and the values were saved as the trained features for the next process. The next process is the segmentation process. Fuzzy rules were generated for the features extracted from the selected portions based on the rule generation functions. The generated fuzzy rules were then classified using the ANFIS classifier. The ANFIS classifier is a combination of the fuzzy and the neural network process. The ANFIS classifier classifies the portions into normal or affected regions. If the portion is classified as normal, means then the particular region in the segmented image is blackened. If the portion is classified as tumorous portions, means then the particular image in the segmented portion is whitened. And finally, we measure the performance of the process with the help of the calculation of accuracy of the classification process. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is present in the source code folder. Right click it and click on run file. The user interface for the execution of the process will display. So we have some 7 images of 7 MRI images. So we have to select any one of the MRI image. So first step is the selection of the input image, and the input image is displayed here. After that, we apply the pre-processing process, which is done based on the median filtering process. Then thresholding is applied in order to select the numerous portions in the input images. Finally, we extract the region of interest within the selected portion. After that, the shift seed points is extracted in the region of interest. So, as the result of the feature extraction, the regions which are tumorous and non-tumorous portions can be identified based on the next classification process. So, the shift feature extraction process is goes. So these are all the selected seed points in the input images. So these regions has to be now classified as tumorous or non-tumorous portions. So the next step is the rule generation process, which is based on the fuzzy rules. So these are all the rules generated for the proposed process. These rules were used for the ANFIS classification process. Then we apply shift segmentation process for the removal of the tumorous portions in the images. So, as we can see, we have segmented the tumorous portion and the normal portion. Finally, we measure the so the same process is based on the Hessian affine seed points, and the rules were generated for the Hessian affine seed points, and the segmentation process is done. Now we are measuring the performance of the process. So the performance of the process is measured based on the accuracy, precision, and the recall value. So we have compared the shift-based process with the Hessian affine segmentation process, and the result is displayed here. Accuracy, precision, recall values for the process. Thus, we have compared two different methods for the segmentation of MRI images with our shift points and the Hessian affine detector seed points, and we have measured the performances based on accuracy, precision, and the recall value. Thank you.